All right. We're glad to be here and to be at JDConf here. And as Bruno was saying, we'll take a look at some of the latest cloud-native Java innovations, especially when it comes to fast startup, and then that's in the performance domain, right? So we'll take a look at InstantOn, CRaC, and native image today. And Rich and I are both from IBM. We work on what IBM offers in the Java space, right? OpenJDK being one of them, and related Java-related projects. So we're excited to be here. And as we know, Java is 30 years old today. Well, not today, but this year. It's 30 plus now, to be exact. And Java's been critical to many different mission-critical workloads and to our industry, right? So it's the foundation for enterprise applications in all sorts of ways, right? Big or small. And as we can see in the last few years, especially, Java has continued to evolve, and a lot of innovations has come to the surface or have been brought to market, right, to make it easier for us to use Java for the next generation of workloads and innovations, right, whether it's for cloud or even for AI and things like that, right? So yeah, and today we'll take a look at some of the cloud-related or cloud-native innovations, right? So and when we talk about cloud, so typically you would think about, so for instance, you don't need to manage as much infrastructure. You leverage a cloud platform to give you what you need to gain flexibility, scalability, and agility, right? Speed to do more with less, hopefully, and also to take advantage of what cloud will offer you, right? When it comes to performance, for instance, security, and cost, right? That's what we think about when we talk about cloud, and what does that mean when it comes to Java, right? And that's what we'll dive into today in the upcoming 30 minutes or so.
All right, I'll take over real quick. So if you're starting down this monetization path, this is considered the heavy lifting part, where we're taking a Java monolith application and moving to cloud native architectures like microservices and serverless. And if you do that, you're going to run into some issues that are very specific to Java. So namely, Java was never intended to run in these types of environments. So typically running in constrained environments like containers, where you're going to need to be able to start instantly and shut down instantly to have effective scaling as your demand goes up and down. So at the heart of the issue is the Java virtual machine and the just-in-time compiler, which I'm sure you're all aware of. So as we all know, the JVM is what executes our Java applications. Initially, this is done by interpreting the Java code byte by byte, which is relatively slow. At the same time, the JVM uses these profilers to go out and take a look at your running code to determine hot methods or methods that are repeatedly called, and then compiles them on the fly. So this running compiled code is 10 times faster than interpreted code. So the real problem is how long and expensive those compiles are. So here's a chart. Let me see if I can get my little pointer. So on the left, we have CPU consumption. As you can see, tremendous spikes at the beginning. These are all associated with JIT compiles. And then also with the memory footprint, we have some big jumps as it needs more and more memory to compile that code. So here, when your Java application is ready, we're going to use the term startup time. That's when it's ready to receive requests. And then we have ramp up time, which is the time it takes to actually optimize your code to run more effectively until we get to steady state. So let's go over the good and the bad. So the good. So what makes Java so popular, at least beginning, was it's device independent. You write it once, you run anywhere. You only change the JVM, you don't change your Java code. So it's been around a long time. It's constantly being improved. It uses a JIT, as I just mentioned, to really optimize your machine code, much more than you can get with doing a static or ahead of time compile. It has great garbage collection. And because the JVM continues to profile and the JIT continues to compile, your Java apps actually run better the longer they run. So there are some trade-offs. So before that JIT is invoked, that code is interpreted, which is relatively slow. When the JIT is invoked, it can cause CPU and memory spikes, which we saw in those graphs. Those CPU spikes, at the very least, can lower the quality of service. memory spikes cause out-of-memory issues. So both the CPU and memory spikes slow down startup time and ramp-up time. As I mentioned earlier, let's go on. So if we had a Java wish list for running cloud native, we obviously want to lower costs. That's the whole purpose behind doing this. We want to use less resources, really charge for what we use. So we need to use as little memory and CPU as possible. In order to be effective in that environment, we need to have fast ramp up and startup times. We need to have high application throughput, and we need to be efficient when scaling up and down, including from zero. So that's the bad news. The good news is that there's the Java community is well aware of these issues, and it's where all the exciting innovation is happening. Lots of companies are spending a lot of capital to get Java workloads to work in this space. So that brings us to a couple of, or three, open source solutions we're going to talk about today. So we have OpenJDK CRaC, we have Liberty InstantOn, and we have GraalVM native image. The first two deal with startup time, and the native image also reduces container sizes. So both CRaC and InstantOn are based on the Linux CRaU feature, which is a checkpoint restore in user space. And the concept is similar to closing and opening your laptop, right? You shut down, and when you open back up, everything comes back to where it was. That's the concept. Let's talk about CRaC first, which is coordinated restore at checkpoint. So this was initiated by Azul back in 2023, so it's relatively new. It's now an OpenJDK project that is essentially a set of APIs to access that underlying CRaU technology. So in order to use CRaC, you need to identify and register some resources, which are sent notifications before and after checkpoint and restores. So resources are things like file handles, network connectors, and streaming objects. So objects that need to be opened and closed. They need to be closed before taking a checkpoint and then reopened after a restore. So here's a really small code snippet where, I don't know if my pointer's still working. Yeah. Okay, so I have this, the CRaC library imported. I'm registering this class as a CRaC resource, and then I'm going to write what needs to be done before checkpoint and after restore. So CRaC has current runtime support in frameworks Spring Boot, Micronaut, Quarkus, and Liberty. CRaC is a Linux-only solution, which shouldn't be a problem because this is meant to be run in containers. So I'm taking a look at one example is Micronaut, which is a really good website if you want to learn more about this. It's got very good documentation and has some starter apps. It supports Java 17, JDK 17 or later. It's polyglot with Java, Groovy, Kotlin support, and it has the typical Java dev support with Maven, Gradle, JUnit, etc. So I don't have time to go into a demo, but I did do one. I ran their starter app running both in normal mode and in checkpoint restore mode or CRaC mode. So as you can see, normally this application, the starter app, takes almost 7 seconds to start up. But after applying the CRaC libraries, I got it down to 500 milliseconds, which is really excellent. So next we're going to be talking about Liberty InstantOn, and I'll head to YK.
Right. So when it comes to InstantOn, it's a full stack solution. So it's a solution that's all the way through from your JVM and your JDK and including your cloud native Java framework all working together to give you that fast startup solution to what you need for cloud native deployments, right? So it's a full stack solution. And then obviously that's built on Liberty and IBM Semruel runtimes. And if we look at Liberty, right, Liberty is essentially a lightweight and a flexible cloud native Java framework, right? It's open source. You can find out more at openliberty.io, and there are resources there for you not only to learn about Liberty, but also cloud native Java topics. And to go with Liberty, obviously there is the IBM built off OpenJDK from IBM essentially. So that's Semruel runtimes, and Semruel runtimes is OpenJDK distribution that's built upon with Eclipse OpenJ9 as the JVM, right? So it's highly optimized for different platforms, including innovations for cloud deployments in the recent years, right? So, and if you want to learn more about OpenJDK distributions, including Samru, you can take a look at this article that Rich nicely wrote, and you can find out more there. And when it comes to InstantOn, right, so we'll spend a minute or two on this one. So it's a full stack solution, and it gives you very fast startup and near-native startup, and you'll see that in action in a bit. And then it's, as Rich mentioned, it's based on the CRaC technology, right? So you do a checkpoint and restore, right? But at the same time, as we know, JVM is still there, so you have all the benefits of the JVM without losing anything there, right? So you still have, if you need to JIT compilation to speed up, to improve your throughput at steady state, that it's still there. And so not only you have fast startup, there's the benefits with the JVM, and because it's a full stack solution, the focus here is to make it as easy as possible for developers and the technical teams to not have to worry about what they need to do before they can adopt the technology. So because Liberty built the support into, for instance, microprofile APIs and Jakarta E APIs and all the different APIs that Liberty support. So then as a developer or as a user, from an end user standpoint, right, when you write your application, you need to worry about what your application has. If your application is largely speaking, you don't have to worry about what you need to bring up at startup. You can just easily, very quickly, you'll see in a bit, to create a checkpoint and then restore, and off you go. So the idea here is not only to give you all these benefits that you're looking for to achieve a very fast startup, but also to minimize the work that the development team may have to worry about to get that behavior and performance right. So yeah, that's in a nutshell, quickly, what InstantOn is about, and we'll see that in action now.
All right, let me stop. Let's stop this real quick. I apologize. The transitions always are painful. Okay. Can you see my screen?
Yes.
To make sure I'm still connected. Okay. So this is the only demo we have time to show. So this one's on InstantOn. First thing I'm going to do is show that I've created 2 Docker files, one to run with InstantOn and one to run without. And if I do a diff between the Docker files, I know I got it here somewhere, you'll see that the only difference is for the InstantOn is we run an additional checkpoint called after app startup. So that's telling it where to take the checkpoint. So that is the only difference. That's the only thing we need to do. We don't have to make any code changes to the actual code. And if I run it without InstantOn, we'll see that the application starts up. It'll tell us here in a second. The application took 8.25 seconds, and I think I'm running it right here. This is a UI associated with it. Okay, let's kill that. And now we'll run with InstantOn. So that was 8.5 seconds. And now it starts in 500 milliseconds. I also moved this to Kubernetes, Knative. So Knative is the extension, which is for serverless. So I'm going to, the way that works is that you load an image and when it's not being used, it shuts down. So you're not being charged for it. So if you look to see, if I take a look at the pods, there's no pods running for this. I have started them previously. So if we hit those endpoints, it'll start those up. So here's the one without InstantOn. Let me close this so that you'll get a better indication that it's come back. Well, I'll go ahead and start this, and I'll time it. Let's see. So 1, 2, 3, 4, a little over 4 seconds. And now I'll do it with the InstantOn version. 1, 2, about 2 seconds. Now, you're probably wondering, why isn't it starting in 8 seconds or 3 seconds or 500 milliseconds? Well, the problem is the cold start time of the actual framework that's starting. This is serverless. So in this case, it's Knative. It's usually a 2 to 3 second delay to restart that thing. So no matter how fast you make your application. So it's good to go from 8 seconds to 500 milliseconds, but realize that cold start is also another issue. And I assume that's going to get better too with time. Oh, I wanted to show those pods. So you'll see that both pods are running. And after about 60 seconds of no access, they should terminate themselves. Yeah, the first one's already starting to terminate. So that's that. All right, we'll go back to our presentation. Okay. So the last thing we're going to talk about is Oracle GraalVM native image. So this is the most extreme method for running your Java apps. So I say it's extreme because it basically eliminates the need for the JVM by compiling your code ahead of time. So just like any other compiled language like C. So this will definitely avoid any startup or ramp up time delays, but there are some drawbacks. So first off, compiling ahead of time means everything needs to be known. So this is referred to as the closed world assumption. So no more dynamic code like Java reflection. So this technology is provided by Oracle GraalVM, which is again open source. So it actually has two modes. So one is an extended JIT to optimize JVM performance, and the other is to compile into native image executables. And we'll only be looking at the second part there, the second piece. So by being less dynamic, GraalVM native language is geared specifically for short-lived workloads. So remember, there's no JVM and JIT anymore, and ahead-of-time compiles will never be as optimized as a JIT compiler. Also, garbage collection is not as efficient, which may be a problem the longer you run. But the executable has a very small footprint, so it has a lot of positives. It has very fast startup. So again, it's supported in these currently with some frameworks like Spring Boot, Micronaut again, Helidon, and Quarkus. And for this one, to learn more about this, I went to the Quarkus website. They have some good documentation and some starter apps. So Quarkus is a Kubernetes native Java framework tailored specifically for GraalVM and Hotspot JVM. And as you can see here, it's open source and has a great developer community. So no time for demo, but I'll give you the results. First of all, the startup time is incredible, the fastest yet, but it did take 5.5 minutes, 5 minutes, 13 seconds to compile. So this is one of the drawbacks we're talking about. From a developer, this may not be what you're looking for. And that's the kind of things that YK is going to talk about next.
Yeah, thanks, Rich. So in the last, I guess, 15, 20 minutes, we've seen, we talked through the three different approaches to fast startup that we have tried to share with you all here, right? CRaC, InstantOn, and native image. And let's take a moment to see what they offer, right? So summary view of things, right? So when it comes to startup and ramp up, pretty much all three of them offer us the answers to that, right? So very quickly, when it comes to bringing up your workloads, when you need to do it, deploy things in a serverless environment or even as functions, right? So you have that across the board. And fast ramp up is pretty much there trying to get to just running your workloads, right? And yeah, they all help you to reduce what you need when it comes to CPU utilization, right? So but the same when it comes to footprint, there's a difference, right? CRaC and InstantOn, it's not about reducing what you have today, right? Basically, your install footprint or on disk footprint remains the same, but with native image, because it's compiled to native, right? So obviously, when it comes to what you have and run at the end, it's indeed much smaller, right? So the benefits there go to native image. Then when we look at what the developer, or when it comes to developer and then the developer experience, right, or what the developer has to do within a development environment, there are differences, right? So with CRaC, depending on the framework or what you'll use, then you may have to do more or less. You may have to change what you need to work with, right, and so on. So that's a maybe when it comes to developer experience, depending on what you're working with, right? For Liberty InstantOn, as we mentioned, it's a full stack solution. It's designed to minimize what developer need to worry about, or what developers need to worry about, so that you can pretty much do the way you do development the same, and yet you can just easily create a snapshot or a checkpoint and then restore that and get the full benefits of very fast start and so on and so forth, right? As Rich mentioned, with native image, right, it's a completely different approach from a build and deploy standpoint. Well, not so much deploy, but certainly from build, because you need to build to compile to native and build that and work with that when it comes to deployment, right? So the benefits here go to InstantOn. And when it comes to things like full Java API support, we know that native image doesn't have, you can't do some of the more dynamic operations or use some of the things like the fractions and so on. So that's a no there. And when it comes to class loading, and that's similar, right? The minus, in a sense, is with native image, although there may be workarounds to consider. Now, when it comes to code changes, as mentioned, right, the plus here in our experience goes to InstantOn because it's designed to make life easier when it comes to adopting fast startup solutions for the developer, right? So there's no code changes pretty much required if everything works fine for your applications, if you don't have to worry about things here, right? So continuous security, by today, it's pretty much across the board. You have that, right? Previously, we hit some issues with CRaC, but I think given the latest that we found out and what we've learned, it's there across the board. We know, and then we look at the JVM and what JVM provides, including JIT, right? So when it comes to optimized GC, it's not as great. When it comes to native image, there is GC support, but obviously that's not a full-scale GC solution. And the same for JIT optimizations when you really need to drive towards throughput, right? So there is a bit of a consideration there you need to keep in mind when you go for a native image solution. And lastly, goes back to dev priority as one of the, I guess, key considerations when it comes to the 12-factor app or doing cloud native, right? So with CRaC and InstantOn, yes, there's dev priority, right? But certainly that's not the case with native image, right? But that's by design in a sense, but you have to keep that in mind when you weigh the options and see what will be good for your use cases and what you need to accomplish, right? So this is our view of what we've learned. So if you have thoughts or feedback, let us know, and then we're happy. If we missed something, let us know, then we'll take them into considerations and add to our potentially future versions of this discussion, right? So yeah, all three offer excellent solutions to the problem of slow startup, right? And really evolve the Java space for cloud native, right? At the same time, they have pros and cons, so you need to weigh that, right? As Bruno said when we were welcomed on stage, right? So keep that in mind and weigh what you need for your business and your adoption, and then see which one works best for you, right? And there's also other cloud native Java solutions that we won't get to discuss today given time, right? There is what we call JIT as a service, right? Or you answer where the JIT is no longer needing to reside with your JVM, but can run separately or outside of a JVM, and that brings you further value in terms of saving. And when it comes to this footprint, and if footprint is of concern, right, at the same time gives you the benefit of having just-in-time compilation to optimize what you need to run, right? So those would be that's another topic, I guess, for another day. But these would be solutions when it comes to really making Java good and fast and performing for cloud native deployments, right? So yeah, that's all that we have for today. Because we're excited and we are privileged, and thank you for having us here. And hopefully you find this short talk in, I think, just about 25 minutes good for everyone. And you have any thoughts, let us know. Thank you.
All right, guys, thank you so much for this. This was a great presentation, and yeah, I'm curious to give this InstantOn a try one day. One question I have for you: how do you see? There's another way to take advantage of CPU time in Kubernetes for JVM workloads, where you can configure a deployment without CPU limits for a few seconds in the beginning.
Oh.
So there's this configuration in Kubernetes now that it's called CPU boost. And it literally, you give like, okay, 30 seconds, 60 seconds, whatever. So in the beginning, when the pod is instantiating, the process inside has access to as much CPU as it can get. And then after that amount of time, then the CPU limit gets applied, and then the traditional whatever the application does will have to meet that CPU limit.
Yeah, I think that can help. I think that helps with container size initially, because that's hard to do when you have to weigh in all those the JIT compiles. So that may be a solution to that, but you're still going to start slow.
That's
right.
true.
So that we're trying to get instant startup and instant shutdown. So
yeah. I think we are trying to get that time to peak performance, right?
Yeah.
The warm up
faster. It will be faster, but the whole point behind the checkpoint restore is that we've done that ahead of time and it's saved in the image. So when it starts up, it's ready to go.
Yeah. And by the way, we have I think we have Loyan on stage. Loyan, can you join us?
Everybody.
Right.
Hello.
Hey, how are you?
Good, you?
Yeah, we are all good here. We're talking about startup time, warm-up time, peak performance, Git as a service, checkpoint restore, GraalVM native image, CRaC, and so on. So, Loyan, have you tried any of these things to make your applications faster?
I have tried the GraalVM, but only for POCs, nothing ready in production yet.
So
but I would love to have something in production.
So you went to native image.
Yep.
Did you find that you had to pull out some code, or all the code was transportable, or did you run any issues?
Since it was mainly POCs,
No.
so it was very simple code, so I didn't have to touch anything.
Okay.
I was very lucky.
Hello world, yes. Okay.
Yep.
So, Loyan, one of the challenges that I have experienced with things like native images testing, once you have a native image, you also have to test the native image, because ultimately it's a different thing than the JVM mode of the Java application. And to the speakers here, I think if you have a snapshot from CRaC restored, you also have kind of different thing than you did from testing, or is it really the same thing?
You were two different directions. So the native image does require different debugging tools, right? You have a different executable. And then for CRaC and InstantOn, it's still your normal JVM, and so those tools should work. As far as testing and then hoping for the same thing in the image, I think they would be similar. I think YK has probably more insight than I do on that.
Right, it's similar. So essentially, when you test at steady state, that should be what you'll be getting, right? So that's the idea behind it, right? So.
All right. So, Loyan, you're gonna talk about using AI to test stuff.
Yes.
How can Chang and Rich use AI to test Java performance?
That will be good to know and learn. Looking forward to that. Yeah.
That would be amazing. I saw this last week. I played with doing an MCP server that can run all the JDK tools, JPS, JCommand, trigger a JFR, trigger a GC log, etc. And it was fascinating to see how it could just, give me a heap dump. And then that's my command, give me a heap dump. And then the MCP server went and triggered a heap dump for the JVM that I was interested in. Now, enable GC log. And, has any of you configured GC log? It's a great experience of finding out the right commanders for the command line. So I went in there, so enable GC log for this JVM is already up and running. And the LLM got it right and enabled using JCommand to get the GC log while the JVM is up and running. So I'm like, wow, I don't need to be a JVM expert anymore. But and even people should be, but the LLM was able to get a dump of the memory, the garbage collection stats, and give a summary of the state of the garbage collector. Like pressure, allocation rate, things like that, and even provide some sort of recommendation to enhance of the application. So I think eventually AI will get there in implementing a troubleshooter in production, and maybe hopefully reduce the amount of tests that we have to do. But I don't think it's here for that. So, Loyan. All right, Rich, John, thank you so much for your time. Thank you for your talk.
Thank you.
All right. Thank
Glad
you
to be
very
here.
much.
Right, Leanne, so AI-driven test development. Enlighten us how and why this is the sort of thing that developers should care about now. So the stage is yours. Thank you.
Thank you.